Have you ever wondered what would happen if you built an object made entirely of neutrons? No protons, no electrons, just the quiet neutral glue hidden deep inside every atom? A neutron tennis ball, a neutron mountain, a neutron planet. How far could you go before the universe itself says no more? Because somewhere out there lies a limit, a boundary where quantum mechanics and gravity collide, and reality itself begins to break. Welcome to MindBlown Science, the channel where curiosity meets the cosmos. Every week we explore the deepest questions in physics, space, and existence itself. If you love mind-bending journeys into the universe, hit subscribe, ring the bell, and let's dive into the strange and beautiful frontier of reality. At the heart of every atom lies a tiny, dense core, the atomic nucleus. Inside it, protons push outward, repelling each other with immense electric force. Two protons just 1 femtometer apart repel each other with the same force it takes to lift a 20-kilogram suitcase. That's happening trillions of times every second inside you. So why doesn't the nucleus explode? Because neutrons are there. The silent peacekeepers. They don't repel, they don't attract electrically, but they do bring something else. The strong nuclear force, a glue 100 times stronger than electromagnetism, but only over incredibly short distances. Without neutrons, the universe would simply fly apart.
Add too many protons and repulsion wins. Add too many neutrons and quantum mechanics pushes back. Neutrons are fermions. They obey the Pauli exclusion principle. No two can share the same quantum state. As you pack more in, they're forced into higher and higher energy levels, like hotel guests moving up as the lower floors fill up. Eventually, the energy becomes too high. The strong nuclear force can no longer contain them. They leak out. So even neutrons have their limits. Maybe the strong force isn't enough. But what about gravity?
Individually, gravity is absurdly weak, 10 to the power of 36 times weaker than electromagnetism. But gravity has one unbeatable advantage. It never gives up, and it always adds up. Gather enough neutrons, and their combined mass bends space-time itself. At some point, gravity becomes so strong that even the fastest neutrons can't escape. At nuclear density, that point comes at around 0.1 solar masses, the moment gravity alone becomes the glue. And that's when something extraordinary is born, a neutron star.
Neutron stars are not built, they're forged in cosmic destruction. When a massive star runs out of fuel, its core collapses. Electrons crash into protons, forming neutrons and releasing a storm of neutrinos. In seconds, an entire sun's worth of mass is crushed into a sphere barely 12 kilometers wide, about the size of Manhattan. A teaspoon of this matter would weigh 1 trillion kilograms. At the surface, escape velocity is over half the speed of light. This is matter pushed to the edge of existence, where quantum mechanics and gravity are locked in eternal combat.
Inside, the neutrons resist collapse through degeneracy pressure, a purely quantum force that arises because they can't all occupy the same state. But as mass increases, gravity grows stronger, curving spacetime even more. At roughly 2.5 solar masses, even neutron degeneracy gives way. The star can no longer hold itself up. Spacetime caves in, the neutrons disappear, and a black hole is born, a region where the known laws of physics simply stop working. This is where reality breaks.
So, how many neutrons can you stack before that happens? Roughly 10 to the 57th power. That's a 1 followed by 57 zeros. Too few and they drift apart. Too many and they vanish into a black hole. But right in between, in that razor-thin window, the universe does something miraculous. When massive stars die and form neutron stars, they blast heavy elements into the cosmos. Carbon, oxygen, iron, the ingredients of planets, oceans, and life. Without neutron stars, there would be no explosions, no chemistry, no us.
Neutron stars sit on the boundary between too little and too much, between order and collapse, between existence and oblivion. Stack enough neutrons and reality bends. Stack too many and it breaks. If this blew your mind, leave a like, share the wonder, and subscribe for more journeys into the impossible. Because here at MindBlown Science, we don't just explain the universe, we feel it.